Let's now turn to this confidence interval problem. We have 8 measurements with a sample mean of 3,410.14 degrees Celsius with a sample standard deviation of 1.018 degrees Celsius. Find a 98% confidence interval for the melting point of the tungsten. For this one, we will use the t distribution. The setup will be the observed average plus or minus a number off the t distribution times the sample standard deviation divided by the square root of n. So that'll be the form of the confidence interval. So in our case, it'll be 3,410.14 degrees Celsius plus or minus a number off the t distribution, more on that in a second, times, so I'll leave some space for that, times the sample standard deviation of 1.018 divided by the square root of 8. Okay, now to get the number of standard errors that I want to construct the margin of error, we need to use the t distribution. And in this case, we need to use a t distribution with 7 degrees of freedom, n minus 1. Now the area is supposed to be equal to 98%. That'll be the area in the middle. So I need this area in the middle to be equal to 0.98. Okay, so to do that, we either use the table in the back of the book or else use Excel to figure out what the critical value is to get that. In our case, there's a couple of options we could use. We have t.inv. If I use t.inv, I would use t.inv 0.01 with 7 degrees of freedom, so that 1% of the area lies to the left, and 99% of the area lies to the right, so that 98% lies in the middle. That would return the negative number, negative 2.998, basically. Okay. Another way this can be done would be t.inv of 0.99 with 7 degrees of freedom. And this would return the positive value, so that 99% of the area lies to the left, so 2.998 again. The third way this could be done is t.inv.2t with 0.02 and 7 degrees of freedom, meaning that I want the combined area in the two tails to be equal to 2%. And so either way, again, I get the 2.9979516 figure. That's using Excel. Of course, the other option is to use the table in the back of the book. And so we have the critical value, $2.9979516. And so that's the number that needs to go in parentheses, 2.99795. So multiplying, we get 3,410.14 plus or minus. Then let's figure out the margin of error. So that's the t value. So the margin of error will be equal to that number times 1.018 divided by the square root of 8 for 1.079. Yeah, rounding to 2 decimal places, 1.08. The units, of course, are in Celsius. So there is the 98% confidence interval for the melting point of the tungsten.